Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain about B plus tree index files. B plus tree index files. So B plus tree index files. So generally indexing mechanism is used to search the records from the database. So there are different types of mechanisms are there in the indexing mechanisms. All these indexing mechanisms, the B plus tree is one type of indexing mechanism. So what is meant by B plus trees index files, and what is the way of indexing to find out the records? Well, we are going to see here. So B plus tree indices. So it's an alternative to indexed sequential files. It is an alternative to indexed sequential file. So to do the indexing mechanism on sequential files, the B plus trees are an alternative mechanisms. So the disadvantages of indexed sequential files. So indexed sequential files have and disadvantages over searching mechanisms because of the search key values are not appropriate to the memory source. So because of that disadvantage, the B plus tree index files are going to be the advantage for the another indexing mechanisms. So what are the disadvantages of indexed sequential files? We'll see. So the main disadvantage is what the performance degrades as the file grows. So if the file size is increasing, the performance will be degrading. Since many overflow blocks get created. But periodic reorganization of entries also. Periodic reorganization of that file. The entire file is required because of that taking more number of space and taking more number of size of the file. It has to be reorganization. But advantage of B plus tree index files overcoming the disadvantages of indexed sequential file is what? It automatically reorganizes itself. The tree indicates that what it automatically reorganizes. So the automatically reorganizes itself with small local changes in the phase of insertion under deletion. So the reorganization itself, it takes place for doing all insertion operations, deletion operations, the small or local changes. But reorganization of entire file is not required to maintain the performance. So the minor disadvantage of B plus tree is the extra insertion under deletion overhead. So it takes place an extra version of insertion under deletion overhead, and space overhead also. So generally the indexing mechanism is used to search the values, search the records and retrieve the records. But searching mechanisms also having some different types of disadvantages over there to find out the sequential files, to find out the non-sequential files. So in that indexed sequential files having some certain drawbacks. To overcoming that drawbacks, the B plus tree index files are introduced. But B plus tree files are indicating that what? They are automatically reorganizing itself. With small local changes in the phase of insertion under deletion. And reorganization of entire files is not required to maintain performance. And disadvantages of B plus tree is what? Extra insertion under deletion overhead takes place. And space overhead also. It takes a lot of time. And advantage of B plus tree trees outweigh disadvantages. So these are all the advantages and the disadvantages. So they are used extensively. So the tree is nothing but which contains root nodes, child nodes, and extra nodes, extra links, everything. So which is possible to extensive mechanisms. So here, this is the example of B plus tree. which indicates that what all the root nodes and the internal nodes, leaf nodes and all the data. So the leaf nodes indicates that what each and every record of the data. So that indicates indicate index mechanisms allows primary indexes as well as data blocks. So index blocks as well as data blocks. So all the index blocks indicates that what the search key values. All the index blocks indicates that what search key values. So search key values are indexed or pointed towards data blocks. So here the root node, this one, so based on that search key value, that is a data mojat is a root node. So based on that root node, based on that search key value, the internal nodes are presented. So based on that internal nodes, the leaf nodes also presented. Based on that internal nodes, leaf nodes also presented. So here the internal nodes which contains Srinivasan, Einstein, Gold, these are some data which is having in the form of root nodes, internal nodes, leaf nodes. So each and every leaf node is pointing to the next record of the data. So whenever it pointed towards the next record of the data, it automatically retrieves for display. So whenever you are searching for that particular IDs, whenever you are searching for particular instructor ID or instructor name or instructor department or instructor salary, then automatically that root node pointed to the internal nodes and the internal nodes are pointed to the leaf nodes. So it checks whether the related information is going to be displayed is attached with the internal nodes or not. If it is attached with the internal nodes, it automatically informs to the leaf nodes. Then leaf nodes will point it to the exact data where it is located in the data blocks. So exactly it is pointed to the data block where the actual data gets loaded. So this is the form of B plus tree. It contains both root nodes, internal nodes, leaf nodes, and that leaf nodes are pointing to the data. Exactly what you want to display. But root node and internal node both are compares all the required data is presented or not, and required data is presented based on the search key value is presented or not. So based on the search key value, if it is presented, then it displays, it pointed to the particular data which you want to retrieve. It pointed to that data and it displays. So otherwise it could not find the data is in the block. So if it points to the data, then it will get displayed. So B plus tree index files. So B plus tree is a rooted tree satisfying the following properties. So if you want to say that a B plus tree conditions, if you want to say that B plus tree is going to be displays the data with the following conditions, the following properties. So here all paths from root to leaf are of the same length. So all paths should be from root to leaf node. So root to leaf node means, so this is the root and this is the leaf nodes. All paths from root to leaf node should be the same length. All paths from root to leaf node are the same length, and each node that is not a root or a leaf has between n by 2 and n children. Suppose if the root having one and other internal nodes having 3, then it takes what, then again in each and every internal node having separate ones, then it takes each and every one to display. It takes n by 2 and n children. A leaf node has between n minus 1 by 2 and n minus 1 value special case. N minus 1 by 2 or n minus 1 special case. Suppose this having n nodes, then it takes what a leaf node has between n minus 1 by 2, that is 3 minus 1 by 2, that is 1. 1 is the leaf node. So for each one it has to be 1 or other numbers it has to be displayed. So each and every number has to be displayed. If the root is not a leaf, then it has at least two children. At least two children. It has to be at least two children. If the root is a leaf, that is there are no other nodes. There are no other nodes in the tree. And it can have between 0 and n minus 1 values. 0 and n minus 1 values. Suppose this condition is for only if the root is a leaf. If the root is only one node and which act as a leaf nodes also. So root is the leaf. In that condition, there are no other nodes in the tree. So it can have between 0 and n minus 1 values. But if the root is not a leaf, then it has at least two children. The condition it has to be specified. So if root is this one, if it is the leaf node, then it doesn't have any other childs. But if the root is having childs, then at least it has at least two children it have to maintain. It has to be maintained. So these are the conditions. Based on these conditions, the B plus tree indexing mechanisms works to retrieve the records or to insert the records or to update the records or to do any operation on that particular database. And this is the B plus tree node structure. So node structure which contains what? P1, K1, P2, Pn minus 1, Kn minus 1 and Pn. So typical nodes. So here the P are the pointers. P indicates that what? Pointers from the index from the index nodes, and K1, K2, Kn minus 1 are the search key values. So each and every search key pointed to the next one, and each and every pointer is going to be pointed to the next search key. Again search key pointed to the next pointer. Again search pointer will pointed to the next search key. Like that, the end of the structure is going to be pointed by the pointer. Primary index pointer. So here the pointers to the children's if non-leaf nodes are pointers to records or buckets of records. For all the leaf nodes, if any root node having childs, then here the search key is presented and here the pointer is presented. So pointer pointed to the next leaf node, then leaf node is pointed to the next search key. So next search key pointed next pointer. So like the way each and every pointer is going to be pointed with the search key value in the records. So that search keys in a node are ordered. The search keys are to be ordered in the node. So such keys are to be ordered in the node. That means they have to maintain the sequential order. They have to be mentioned in the sequential order. So the sequence has to be follows like what? K1 less than K2 less than K3 less than up to Kn minus. That means 1, 2, 3, 4, 5, 6, 7, 8. Like that they have to follow. All that search key values. So initially assume that no duplicate keys. Address duplicates later. So here the each and every node structure represents a pointer to the next search key as well as search key pointed to the next pointer. In the index file. So leaf nodes. What are the leaf nodes in B plus tree? And what are the properties that follows by the leaf nodes? So here the properties of leaf nodes. So generally leaf nodes are the last nodes which are child nodes, which contains what? For I equals to 1 to n minus 1, the pointer points to a file record with search key value ki. If Li, Lj are the leaf nodes, suppose assume that if Li and Lj are the leaf nodes, then I less than j or Li search key values are less than or equal to Lj search key values. Lj search key values. If Pn points to next leaf nodes, Pn points to next leaf node in a search key order. In a search key order. So the pointer to the towards next node in the leaf nodes. So here take an example. Here branded calipari crick or the records which want to display here, which you want to display at this moment. The pointer, the structure follows what? One is pointer, the next search key value. The next search key value. Search key indicates what? Key. The next pointer P2, the next search key. Pointer P3, search key value P3. Like that it follows. So here the leaf node is also following same. So the pointer, the next search key. So this is the pointer, this is the search key. And this is the pointer, this is the search key. This is the pointer, this is the search key. So based on that search key value, it pointed to the particular record of the data. So here also the search key value is what? Branded. So Branty. So it pointed to that particular location. Then it displays what? Branty record of the data. So like the way the leaf nodes are working with the help of a structure, node structure. It pointed to the particular data. And non-leaf nodes, if any B plus tree is not having any leaf nodes, then what it takes and what it points. So non-leaf nodes form a multi-level sparse index on the leaf nodes. For a non-leaf node with m pointers, all the search keys in the subtree to which p1 points are less than k1. That means the number of search keys are less than that number of points. For 2 less than or equal I less than or equal n minus 1. So here all the search keys in the subtree to which pi points have values greater than or equal to ki minus 1 and less than ki. So like the way the search keys values and pointers are greater than that or equals to non-leaf nodes. So here all the search keys in the subtree to which pn points to have values greater than or equals to kn minus 1. So the condition represents that what all the search key values should not be greater than that pointers, or else search key values are equal to pointers. Search key values should not be greater than the pointers, as well as search key values are equals to pointers. Then only the search key values in the node structure is going to pointed to the records of the data. So now the pointer pointed to the particular record, and the record which is pointed by the search key value is going to be displayed. So here another one example of the data. So suppose here the B plus tree which points to both search key values as well as pointer, which having both pointer as well as search key value, is both having pointer and a search key value. So here each and every root node having more than 5. So B plus tree instructor file is what? N equals to 6. So leaf nodes must have between 3 and 5 values. So based on the condition is what? N minus 1 by 2. So n minus 1 by 2 is nothing but what? 6 minus 1 by 2. So and n minus 1. So that is nothing but we can have 3 and 5. In between the 3 and 5 values, the leaf nodes must be having. So as per this formula, as per this property, here the leaf nodes are 4 and here the leaf nodes are 4. So that itself it's having the property the leaf nodes must have between between 3 and 5 values. 3 and 5 values. And non-leaf nodes other than root must have between non-leaf nodes other than root must have between 3 and 6. So non-leaf nodes other than root, so which contains must between 3 and 6. And the children nodes are having n by 2. Then n by 2 means, so 6 by 2, that is 3. So either 3 and 6, in between 3 and 6, the non-leaf nodes are to be presented. Non-leaf nodes are to be presented. But here from this diagram, we can assume that we can say that the root node having that leaf nodes, and that leaf nodes must be between 3 and 5 values. Leaf nodes must be between 3 and 5 values. And root must have at least 2 children. Root must have at least 2 children. So here from this diagram, this is the root node which having 2 children, like this one and this one. So here 3 children are there. But as per the property, we can assume that we can say that root must have at least 2 children. So here from the above diagram, we may have 3 children. So no need to problem. So there is the property satisfied. There is a property satisfied. And the observations about B plus trees. So from the all B plus tree index files, B plus tree indexing and non-leaf nodes and leaf node structure, based on that all, we found that some observations of that B plus tree. We found some observations of that B plus tree. So what are those observations? Since the internode connections, that is nothing but what? Internode connections are nothing but what? Root node as well as internal node as well as leaf node. So all the leaf nodes are interconnected. Because we are going to say that all the leaf nodes, node structure follows what? Node structure follows either pointer as well as search key. Either pointer and search key. It follows what? The pointer and search key structure. So since the internode connections are done by the pointers, logically closed blocks need not to be physically closed. So the internode connections are done by the pointers are logically closed. Blocks need not to be physically closed. So we just want to close them in logical way. But blocks need not to be in physical close. So we don't want to delete the blocks. And the non-leaf levels of the B plus tree form a hierarchy of sparse indices. So it forms a hierarchy of sparse indices. So sparse indices are nothing but what? Taking or selecting some certain search key values. So taking or inserting some certain sort of search key values. And the B plus tree contains a relatively small number of levels. B plus tree contains a relatively small number of levels, and that level below root has at least 2 into n by 2 values. So the level below root before the leaf node and before the root node, it has at least 2 into n by 2 values. And next level has at least 2 into n by 2 into n by 2 values. 2 into n by 2 into n by 2 values. That means if a node is having a 6 number of internal nodes, then it must having 2 into 6 by 2 into 6 by 2. That indicates that what? 2 into 3 into 3. So that at least 3 into 3, 9 into 18 values has to be presented. So it contains a very relatively small number of levels. The number of levels to be presented. If there are k search key values, in the file, the tree height is no more than log of n by 2 of base k. So thus, searches can be conducted efficiently. The searching mechanism for the records is to be conducted efficiently. And insertion and deletion to the main file can be handled efficiently. Insertion and deletions to the main file can be handled efficiently because the search key value is pointed to the next pointer, as well as pointer is pointed to the next search key values. So whichever the search key value is pointed by the pointer, then it takes place to insert or it takes place to delete. So at that moment, the taking insertion and deletion is to be efficiently. Taking insertion and deletion is to be efficiently, as the index can be restructured in a logarithmic time. Restructured in a logarithmic time. So at that moment, the physical, both physical structure and logical structure is going to be represented. So this is all we have to be observe some observations from B plus tree. B plus trees, because of having both root nodes, internal nodes, and leaf nodes. So this is all about observations of about B plus tree. So once again, we revise the topics which we discussed in this session. So what is mean by B plus tree actually? So what is the B plus tree index files? So what is mean by indexing mechanism? So basically, what is mean by indexing mechanism? So indexing mechanism is to find the records based on the indexes that we have provided. So indexes contains what? Search keys and search key related to the records. So here the disadvantages of indexed sequential files, and to overcome that indexed disadvantage of indexed sequential files, we are having some advantages over B plus tree index file. So what are the advantages? Reorganization of the files. Reorganization of the file itself, it is manages itself, it is the insertions takes place itself, it is the deletion takes place. So here reorganization of entire file is not required to maintain performance. But the disadvantage is what? So taking overhead, so taking a deletion and insertion overhead to place. And this is the example of B plus tree, which contains both root nodes, internal nodes, and leaf nodes. Both root nodes, internal nodes, and leaf nodes. And every root node must have at least two children. Every root node must have at least two children. So as per the two children, they may have a more number of leaf nodes, and for each and every leaf nodes, for each and every internal node, it may have at least 3 to 5. In between 3 to 5, the leaf nodes has to be presented. If root node is not contain any leaf nodes, then root node is only the leaf node. It will be acting as a leaf node. So like the way it follows the structure. And here the B plus tree root is to be following some certain conditions or certain properties. So which contains the root node having at least two children, and each and every internal node having at least 3 to 6 nodes. So here the structure B plus tree node structure. So the node structure represents what? The combination of both the pointer as well as search key. So pointer pointed to the search key, and search key pointed to the next pointer. So if the search key value is pointed to the particular record, then that particular record based on the search key value is going to be displayed. So that is the way of node will be presented. And leaf nodes in B plus tree. So how the leaf nodes are pointed with the search key values, and based on that pointers, based on that search key values, the value is going to be retrieved. The value is going to be retrieved here. And non-leaf nodes. So non-leaf nodes, what will happen? Non-leaf nodes are nothing but the leaf nodes doesn't have any, the internal nodes doesn't have any leaf nodes, and that leaf nodes must be equals to the pointers as well as search key values. The leaf nodes must be equal to the pointers as well as search key values. And here the example of with the leaf nodes, non-leaf nodes, the example of non-leaf nodes, which contains both pointers as well as search key values. It contains both pointers as well as search key values. So here as per the properties, if taken as instructor file n equals to 6, then it takes the files, the leaf nodes must be between 3 and 5. But for the non-leaf nodes, it may have the 3 and 6. It may have 3 and 6. And here the observations we followed here. The observations are nothing but as per the internode connections. As per the internode connections are done by the pointers. So logically close. They may logically close but not physically close. And that contains, the P plus trees contains a relatively small number of levels. relatively small number of levels. The levels should be below at least 2 into n by 2 values, and the next level, that's the leaf node, and next level is at least 2 into n by 2 into n by 2 values. It should be arrows. If the case search key values in the file, the tree height is no more than log of n by 2 sk. Log of n by 2 sk. So insertion or deletion to the main file can be handled efficiently, as the index can be restructured in logarithmic. Structure can be restructured in logarithmic time, and based on the time it has to be restructured again. So this is all about B plus tree node structure, B plus tree index files, and B plus tree observations. So that is about B plus tree index files mechanisms. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.